These are the 8.5 notes. Today's objective is to use similarity theorems to prove that triangles are similar. Okay, for your note cards, you have two theorems in this lesson. That's Theorem 8.2, the side-side-side similarity theorem, and Theorem 8.3, the side-angle-side similarity theorem. These are much like the congruency theorems when we were talking about congruent triangles. The only difference here is the sides aren't congruent to each other, they're proportional to each other. So the side-side-side similarity theorem says if the lengths of the corresponding sides of two triangles are proportional, then the sides are similar, then the triangles are similar. And then Theorem 8.3 says if one of the angles is congruent to the angle of the second triangle and two of the lengths of two of the sides are proportional, now remember those two sides have to be surrounding that angle, then the triangles are similar. So again, the only difference here between the theorems that we had before with side-side-side and side-angle-side are that the sides aren't congruent to each other, but they're proportional, and that's what makes the triangles similar and not congruent. So the problems that I'll be showing you are on pages 492 to 494, numbers 6, 10, 20, 28, and 32. So on number 6 on page 492, they want to know which pair of these triangles is similar, and then once we find the similar pair of triangles, we're also going to find the scale factor. Now, right away, I'm looking at triangle JKL, and I'm looking over here at RSQ, and I can tell that 8 divided by 2 is 4, and 6 divided by 2 is 3, so I'm thinking maybe this RSQ is half the size, but if I take 12 divided by 2, that is not 5. So in order for that to work, all three sides have to be proportional to the three sides of the little triangle. So I know JKL is not similar to RSQ, so I'm going to try JKL and MNP. So this one's a little bit harder because I've got decimals to deal with. So the one that's not a decimal, 8 over 6, that reduces to 4 over 3. So I need to see if all the other ones are 4 over 3 or 1 1/3. So if I do 6 over 4 1/2, if I just go ahead and divide that out, 6 divided by 4 1/2, I'll see if I get 1.3 repeating, and that does equal 1.3, which is the same thing as 4 over 3. And then I'm going to try 12 over 7 1/2 and see if that reduces to 1.3. And that one is not. It's 1.6. So this doesn't equal these other ones. So JKL is not similar to MNP either. So let's try MNP and QRS. So NP is 6, and that goes with RS, which is 4, and that reduces to 3 over 2, which is 1.5 if you divide it. And so I'm going to try all my other sides. MN, which is 4 1/2, goes with 3, and if I divide that, that's also 1.5, so that's 3 over 2. And then if I do MP, which is 7 1/2, and divide it by 5, that's also 1.5, which is 3 over 2. So the similar triangles are triangle MNP is similar to triangle QRS. Now make sure you get the letters in the right order. So the scale factor is just this thing that we multiply by, which is 3 over 2, or 1.5. Now truthfully, I probably would write the scale factor as 2 over 3, and here's the reason. We're getting ready to do, and I want to put equal there, just put an or. We're getting ready to do dilations, or some of you in 8th grade have been doing that on Study Island. But the reason I would write it as 2 over 3 is because if the bigger one is the original, then to get from the original to this smaller one, I would have to multiply by 2/3. To get from the smaller one to the bigger one, I would multiply by 3/2. So it totally depends on what your original triangle is when you're doing this on a coordinate plane. So I'm just going to say that the first one, the bigger one's the smaller one, which means that my scale factor has to be a fraction less than 1 in order to get a smaller triangle. Okay, on number 10 on page 493, we're just supposed to tell whether these two triangles are similar to each other. And on number 10, these two triangles are similar to each other. And I know that because of the side angle side similarity theorem, because I know that PM is congruent to RM. And I also know that angle PMS is congruent to angle RMN. And then I know that MS is congruent to MR. So that's the side angle side theorem. And so for the similarity statement, I just want to put that down, that triangle SMP is similar to, now be careful here, since I started with S and went to M, I have to make sure that I start with the side that's got 2 marks on it on the other triangle. So I want to start with N. So triangle NMR. Those two triangles are similar to each other. Now number 20 on page 493, I think that there's probably one thing that's missing from this diagram, and that is that these two lines on the top and bottom are parallel lines, and they should have marked that with arrows here. So if you want to mark that in your book, then that's fine. So on 20, we're supposed to find the measure of angle EDC, which is this angle down here. So since these lines are parallel to each other, and this line is a transversal, BD is a transversal, and I know that angle ABC is 45 degrees, that also means that angle EDC is also 45 degrees. Okay, now number 28, we're supposed to tell if we think that these two triangles are similar to each other. If they are, to write a similarity statement, and we also have to find out what the variable equals. So that's the 3 things we have to do in this problem. Now, since I don't know one of the sides, I cannot use the side-side-side theorem to prove that these are similar. I'm going to have to use side angle side. Now, there's another theorem, angle, but I don't know any of the angles, or at least I don't know 2 of them. I know one is congruent, and I'll show you that in a minute. So the angle that I know is congruent in these two triangles is angle E, because they share angle E. So I'm going to need the 2 sides that are surrounding that on both triangles. So I need side EH, and I need side EJ of the big triangle, and then I need side EF, and I need side EG of the smaller triangle. So EH is 6 plus 2, which is 8, and EJ is 4 plus 8, which is 12. EF is 6, and EG is 4, and I got all of that straight from the diagram. Now, in order for these triangles to be similar to each other, 2 of their corresponding sides would have to be proportional. Now, I don't really know what the corresponding sides are because this smaller triangle can be turned inside of that larger triangle. So I'm just going to have to try some things. So if I use 8 over 6, does that equal 12 over 4? Well, no, because 12 over 4 is 3, and 8 over 6 is much smaller than 3, so that wouldn't work. But maybe EH goes with EG, so 8 over 4, does that equal 12 over 6? Well, yes, because both of those equal 2, so the scale factor is 2. So these two triangles are similar. Now we're just going to have to get our similarity statement lined up. So I know that EH needs to go with EG. So triangle EHJ is similar to, remember EH needs to go with EG, so triangle EGF. That's our similarity statement. So now for this last one, I know that HJ should go with GF. And since I know that GF is 5 and that the scale factor is 2, that makes HJ have to be 10. So HJ is 10, which is the variable R. Okay, on number 32, we're supposed to find the value of X here. And the first thing I would need to do is kind of prove that some triangles here are similar. Now I see 3 triangles in this picture. This smaller triangle here, the great big triangle here, and then you have another smaller triangle on top of the red line. Now the 2 triangles that I can prove are similar to each other are the smaller triangle here and the very large triangle here. And the way I can prove that those are similar to each other is by angle. So the angle theorem. They share this angle down here, and then they both have a 90-degree angle. The large triangle does here, and the small triangle does here because the one supplementary to it is also 90 degrees. So that makes them similar. So I know their sides are proportional. So that makes the bottom side of the large triangle, which is 125, would be proportional to the bottom side of the small triangle, which is 25. And then the height of the large triangle, x plus 20, would be similar to the height of the small triangle. And I didn't think I knew that height at first, but it's actually over here, it's 20. So there's your proportion to set up and cross multiply. So cross multiplying 125 times 20 is 2500, and then 25 times x plus 20 is 25x plus 500. Subtract 500 and you get 2000, then divide by 25 and you get 80. So this distance right here is 80 meters.